We are streaming.
That would confuse you. It's alright.
Live.
I know.
After crossing the river. Are you kidding me?
After what?
Did you see the other with the chocolate?
Bro, that's what I'm looking at.
Oh yeah.
Josh, put that away. Chemistry out.
Yeah.
I just don't know how to.
I will come around and have a look at your work. Here we go.
What you got? Really tracks. But that's not a real number. And mathematically, that's a real number. But that's not a number you can use.
What is this supposed to be?
How'd you get that?
I really like that. Like, I'd be so down to do that.
So to pull your calculator, make sure you can do that. Because that's a specific function. And you don't want to use the one you use for sign notation because it will break. It will go, I don't know what to do with this. So make sure you're using the right number. You also get 3.2 times 10 to the minus 6. Excellent. Excellent. Well, we do a lot of sig things. But good.
Wait, so if
And
it is specified, do we just want them to teach it?
I'm going to teach you sig figs maybe today for PH. I've already sort of hinted at it previous to this.
No, did we miss
Because
anything?
it's a logarithm. Pardon?
Did we miss anything?
Yes.
There's a few go for
When is the next G?
We did the lab.
on Friday.
Yeah.
Yeah, but like what day? Like Thursday or? Oh, it's Thursday because there's no school Saturday. Oh, hell no.
Wait, it's due Thursday?
Oh, we have a quiz next class.
What's due Thursday?
On what?
JK.
What?
Wait, is that like April Fool's?
No.
Oh, yo, what happened to
Uh,
April Fools, bro?
Sections J and J.
Mrs.
We're
Sullivan.
gonna do.
Mrs. Sullivan on purpose.
That's good.
No, we should reschedule it. What
We're
day
gonna
is
do
April
May
1st?
Fools, bro. May Fools.
Yeah, I know.
You got back, I think.
That's not gonna stop us. We can still go.
You're not gonna stop us.
May Fool's.
No, we're just
First day of May. We're
Okay.
staying at my house or something.
I'll go over that one.
I give both things, bro. It's Josh. Then, do you need a desk?
no.
Notes out then. Let's get ready to go.
I got my notes right here. Me and Sam are actually more ready than everyone else.
Yeah, but if you're talking to other people, then I'm going to assume that you're not. Because I also assume that Tio's not ready. And clearly he isn't. Still getting his notes out. Let's go. So reminder, you have a quiz on
Just kidding. Next class.
next class. It is not on L. It's on JK. JK. So, just as a reminder, why don't we just pull that up? Today, that is. And. Is that opening or not? Isn't it?
That's enough to get April Fool's joke.
Okay, just a reminder, J was just the intro to acids and bases, so a review of the properties from grade 10. What exactly is an acid and a base and how we define them. Traditional balancing with acids and bases, acid plus base gives the salt plus water. How to identify them. Is it a molecular compound or is it a ionization and nutrimolecular? So sugar doesn't dissolve in water to become ions, but acids often do. And then we define Arrhenius versus Bronston-Lowry. So Arrhenius was the old one, and how I remember that is that they're in alphabetical order. So Arrhenius is the older one, Bronston-Lowry is the newer one. You should know some common acids and bases and what they are and where their properties are. Bronston-Lowry is proton transfer, so you can be a proton donor or proton acceptor. You no longer have to have hydroxide to be a base. And what makes a good acid versus a good base? If you want to be able to attract H+, you have to be able to attract it, so having some negative charge around, some lone pairs, and some theoretical knowledge in terms of what makes an acid so strong. It has no empty space to it. It is a concentrated charge simply on a proton. So there's a lot of detail, sort of theoretical detail in J, and a lot of definitions. Conjugate acid-base pairs and be able to identify them. So an acid and base conjugate are the same, except they differ only by a proton. So their charge will be different, and they will have a plus or a charge difference and an H difference. And then K started off with conductivity. There's my mouse. So things that give off a lot of ions will conduct more. And so this was the introduction essentially to weak acids. So you can have two acids that have exactly the same concentration, but their conduction is different because citric acid is a weak acid and not all of it comes off as ions as opposed to HCl, which is strong. So there's a mix here of grade 11 one-way reactions that is going to be consistent, because whenever you have a traditional strong acid, it's going to go 100% and you'll just calculate the pH directly. But if you have a weak acid, we're eventually going to get back into ice tables. You have to figure out how much of it dissociates. We're going to need to figure out how much is left over. So this is the introduction to that. What is the difference between a strong acid and strong base? The strong acids and strong base. The strong acids are on your table. The strong bases are not, with a couple of exceptions. Anything with a hydroxide, not an alcohol, but a hydroxide, is a strong base. Conjugates again. Oh, specifically conjugates of anything that's strong can't go backwards. So they are the example of it's such a weak base, it can't even be a base type of definition. So they are members only by definition, because they're conjugates of something strong. In much the same way you'll introduce someone as the husband or a spouse or wife of this famous person. You never hear their name. They're only famous because of who they're attached to. Compare the relative strengths of acids and bases using the table. So we used our table. I won't go through that, but you can find the arrows on the side that tells you what is strong versus what is weak. And so there's lots of questions you can do is which one of these is the strongest acid? Which one of these is the strongest base? And you look them up on your table and you compare their relative locations. What kind of things are amphiprotic? So what things can gain a hydrogen and lose a hydrogen? So that can both gain and add. It's got a negative charge, but it's also got an H. That has a negative charge and it has an H. This has no negative charge to attract it, so it can only give it off, so that's not amphiprotic. That has no hydrogen, so it can only accept, so that is not amphiprotic. That was the two of them. So we hadn't really gotten into calculations yet. A few little ones. And then J, it's J. And then in PLOL, before you left, we had started getting into calculations. Next week, this week is the quiz. Next week, Monday and Tuesday, whichever day we have class, we will have the last day of our lab. So at that point, you know how to do a titration. You're going to calculate the Ka given your data for your particular acid, and you should be able, with that, identify the acid that you have. So that's early next week, Monday or Tuesday, and this week is finishing off L and the calculations. We have a number of understandings. Number one, the pH scale, which you already know, but also understanding the pH scale is a ratio of hydroxide to acid. So it is never absolutely, if the solution is acidic, it always has some acid there. The idea that something can have more acid and more base and still be neutral. The reason pH is neutral at 7 is because at 25 degrees Celsius it is 1.00 times 10 to the minus 14 in terms of the kW, and they spread out in equal amounts. At any other temperature, the neutral location is not 7. It could be 6.5, it could be 7.5. It could be a variety of different results at different temperatures. You can assume 25 degrees Celsius unless told otherwise. It's usually a reasonable exception to make. And then we gave you some calculations. Kw is H plus times OH minus. You can now use chemistry 11 to go, well, this is a one-way reaction, strong base. I now know how basic it is, and that doesn't require any calculation. It's just basically double it because it's stoichiometry. But now that I know that, I can use the calculation to figure out how much acid is in there, because we know the Kw for the dissociation, and we know the amount of hydroxide, so we can calculate the amount of acid in any particular solution. I think that was close to where we left off. Sorensen. Calculation of the pH, which you just did just now. So just now I said, well, you've got a pH is equal to 5. So very quickly, I was very impressed after a long break. Well done. You very quickly said, oh, well, that's 1.0 times 10 to the minus 5. And if it's 5.5, then you go, oh, it's 1.0 times 10 to the minus 5.5, which is also good. But that's not a real number you can write down. We have to take that. The number for scientific notation always has to be a single digit. So then you have to go to your calculator and punch in, what is 10 to the minus 5.5? And I think it was 3.2 times 10 to the minus 6. And this is a very good check if you're on the right track. Because if you look at this number, you might not know what the answer is, but you go, oh, well, it's times 10 to the minus 5.5. So it's going to be around minus 5. Minus 6 is close. And it's even more negative because we got the 0.5. So it's gone towards minus 6. We got 3.6. That makes sense. If you got an answer, it was 10 to the minus 12, you know you've done something wrong because that's nowhere near minus 5. So use that to do sort of a quick guesstimate in your mind and then check. Lab day stuff. Quick head calculations. Actual calculations. I think at this point everybody was like, no! I don't think we finished that. So now with that newfound knowledge, given this H3O plus, what would the pH be? If you know the pH, what is the pOH? So, if we know the pH is 0, what is the pOH?
Probably pretty big.
It is probably pretty big. I might leave that for you to discover then. But this one's fine, right? If you go 1 times 10 to the minus 0, then the pH is 0. Goes to no. If it's 1 times 10 to the minus 1, then the pH is 1. So 1 times 10 to the minus 2 is 2. Excellent. Now, if this is 1 times 10 to the minus 1, and these two multiplied together have to equal 1.0 times 10 to the minus 14, then if this side's minus 1, then that side has to be minus 13. They have to multiply together to get us minus 14. So this 1 times 10 to the minus 2, what does this one have to be?
7.
Not 7. 1 times 10 to the minus 12. This is a straight concentration. It's not a pH or anything. Then, knowing that, pOH is equal to the negative log of the concentration of OH minus. Do that calculation, find out what the pOH is for all those. So fill in the columns because I want this pattern to be ingrained. And second nature.
Not 14, 13.
Because that's just.
So we're getting everything from this column. If the concentration ratio plus is this, what's the pH? What's the OH minus? What's the pOH?
So it would just be 13 kilograms.
Everybody must discover this. Hmm? You might see a pattern, and it might take you not very long to fill out in that case. Excellent. So from the first one, if you have if you have a concentration ratio plus, how do you calculate pH? It's the negative log, so it's the exponent times negative one. Yeah. For the OH, we know that both the H plus, H real plus, and the OH should multiply together to give us 1.0 times 10 to the minus 14. So if you have times 10, like the second row, if you have times 10 to the minus 1.
It's just the opposite. It should be this.
Yeah,
This would go here. This would go this.
Yes, I mean, that's an easy way of seeing it.
Yeah, nice. I like that.
What I'm hoping you see is as you go along, yeah, you should also see that they're adding up to minus 14. Yeah.
Because it has to be water has its like thing is 1 times 10 to the negative 14, right? So if you look at 10 to the 0, and you look at and it has to like both of them together have to multiply the 10 to the negative 14. And you just multiply exponents, you just add the exponents. So you just look at it, you just add, it has to just add up to. Yeah. And then 2 and 12, 13, 11, 14.
In a way, yeah, and because I want it to be engraved. You've done exponents in math classes, right? Like that's a thing you do in pre-calc. Good. How are you? Why minus 10 for the top? Nope, I didn't write that. Minus 14.
Could you explain the top part in green, like what is the significance of KW?
Oh, so that's a formula we now know, or you do have to.
For this specific
For
equation?
for all of acids and bases. So the KW, the K plus and OH minus multiplied together. The KW is 1.0 times 10 to the minus 14. So
pH is 0.
So if that pH is, well, if we're using this calculation, then that number is 1 times 10 to the minus 0, if we just do the first column. And that then, and we know that it has to equal that's a 0, not a 6. So what is the concentration? What must this number mean if then multiplied together equals minus 14?
That is the concentration of OH.
Yeah, because they have to multiply together to equal the KW. The KW is that.
So then that divided by the concentration of
Yeah, and what is that number? 1 times 10 to the 0.
or no. What is it? 1 times 10. 1 0? Yes, 1.
It's 1. So that's just 1. So you're just taking this and dividing by 1. And then, so that's why you get, for that, the concentration of OH minus
Oh, that's just so great. That's
is equal to 1.0 times 10 to the minus 14. Now, if we take any of these and we switch it and we go, oh, well, this is times 10 to the minus 1, and this becomes minus 1. And if this is 1.0 times 10 to the minus 1, then what must this be if it becomes times 10 to the minus 14?
If you're dividing it by 0.0.
Yeah. Or to do really quickly exponent rules, you're divided by 1.0 times 10 to the minus 1. I mean, those cancel. What's 10 to the minus 14 over 10 to the minus 1?
10 to the minus 15? Minus 13?
Yeah, minus 13, other way, because you minus and negative, it goes the other way. So your answer for this one, hydroxide, is now 1.0 times 10 to the minus 13. And then if you make this minus 2, what does that answer become?
Minus 12.
Minus 12. So in all cases, those two numbers put together, you should always see that 14 coming up over and over and over and over and over and over and over.
Cool. Thank you.
Well, so we can come up with another rule. Has there anybody not done this? Anybody not done it? Because I can pause. Okay. Assuming then that you have this continuing down, let's go 3, 4, 5, 6, 7, 8, dot, 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 all the way down to 14. This continues 1 times 10 to the minus 11, 1 times 10 to the minus 10, dot, 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 to 1.0 times 10 to the 0. And then you end up on this side with a POH of 14, 13, 12, 11, 10, dot, 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 dot. From that relationship, and the purpose really of the table is to say, well, if we know the concentration of H plus times the concentration of OH minus must equal 1.0 times 10 to the minus 14 at 25 degrees Celsius, and I'm not going to say that every time, and I'm just going to assume that. What can we say about POH and pH?
They have to add up to 14.
They have to add up to 14. Numbers, concentrations are multiplied, but logarithms are added because they're the exponents, and you add exponents. Does that make sense? And the reason, of course, is if you had 10 to the 5 times 10 to the 3 without using your calculator, what's the answer? Right? 10 to the 8.
It'd be the pH of OH.
Question?
No.
Question?
No.
So when you multiply, exponents get added, and logarithms are essentially taking a number and turning it into its exponent.
Right.
And so we can just add them. Is it this or something else?
Is what that or something else?
No, what you're asking questions on.
Oh no, we were just like talking about is POH just the pH of OH? No.
Yes, yes. So the formula for pH is equal to negative log of concentration of H plus. So the POH is the,
Negative log of the concentration of OH.
yeah,
But like, when we're saying pH, do you mean like pH like H is in the symbol, or just pH is in like the straight up pH where it's like 0 to 14?
they're the one and the same. When you say pH and it goes from 0 to 14, that H stands for H plus. That is how they calculate it.
Oh.
And it doesn't go from 0 to 14. You could have a pH of -1. Because if you had a concentration, where your H plus is equal to 1.0 times 10 to the 1, what is that in regular numbers? We'll say molar. That's 10. So what is the pH? Not 10. What is the negative log of 1.0 times 10 to the 1? If I put it right here, 1 times 10 to the 1, what would you do to move it to that column? What would it become? 1. Well, not quite 1. Negative 14 didn't become negative 14.
Positive 1. Negative 1.
Negative 1. It already is. If I have times 10, oh, that may have thrown you off. If this is times 10 to the 1, that's yeah, I'm going to erase that entirely. There, no evidence. This is positive 1. Then this would be -1. So you can have a pH of -1. If the pH is -1, what must be the pOH? 15. Because they have to add together to being 14. The concentration of OH minus would have to equal 1.0 times 10 to the minus 15, a really, really small number. But it doesn't go from 0 to 14. It's just 0 to 14 is where we commonly expect it. We will, even in a regular chemistry lab, you only encounter 10 molar acids when you need to dilute them to something else. That's how they arrive, as 10 or 18 molar acids. That's their most concentrated form. And then you dilute them down to something you need. Nobody works with them because that would be insane, unless you're in mining or something. And then you might shove concentrated acid at something. But even then, not 10 molar. So we don't commonly encounter it. So the idea is that it's 0 to 14, just because those are the numbers you see the most often. Okay. Pardon? To the table or down here?
Yeah, down there.
Down there? Okay. Let's give you. Now you've done the anti-log.
Was it like sneeze or like yell?
So we can take the pH by taking the negative log fairly easily. A little bit of practice with the anti-log. The anti-log is the 10 to the x button on your calculator. It is not the scientific notation one. And this is just a matter of how your calculator is programmed. Your calculator will be programmed in a particular philosophy of mathematics. And many types, you'll have a 10 to the x button that is made as the anti-log. It's to take a logarithm and turn it back to a regular number. Your scientific notation one only accepts whole numbers because you're writing in scientific notation. It's there so you can quickly put in a scientific notation and it's a different button. Know which one they are. So the one that's for scientific notation, don't use that for the anti-log. It often, but not always, and if the answer is not always, then it might work either way. But if it's for scientific notation, it often will just, if you put in a decimal, it'll just round it.
What does that say in brackets?
Not the scientific notation one. It's probably not completely clear. But, so, if I give you the following pH, give the concentration of H plus. 3, 3.5, 4.37, 7.5. Ooh. Not that one. 7.40 and 7.38. How many of you are in biology 12? Have you done the lungs?
Yeah.
So what's the significance of 7.4 and 7.38?
Couldn't tell you.
That's the pH.
Have you done hemoglobin and attaching oxygen and not attaching oxygen? Are you in biology 12?
Yeah.
Your lungs are more acidic or less acidic than your tissues?
Less acidic.
They are
More.
more acidic? Why would they be more acidic?
Because you didn't respond well to my answer when I said it's less acidic.
What's going on at your tissues?
It's like exchanging oxygen.
Exchanging oxygen?
and
What's it giving off?
CO2.
CO2. What does CO2 do in water?
Expand.
That would be really bad.
Yeah.
CO2 plus water makes, is a weak acid, carbonic acid.
Carbon, like itself.
Yeah. This is how your body, about 25% of your CO2 is carried by the hemoglobin, in contrast to oxygen, in which like 98% of the oxygen is carried by hemoglobin. Hemoglobin doesn't just carry oxygen, also carries a chunk of the CO2. Not all of it though. And so this gives up. So this is happening at your tissues as they're undergoing cellular respiration. This makes your tissues more acidic. Of these two numbers, which one's more acidic? 7.38. Why?
Because it's lower on the
It's lower down, yeah. Some I'd ask because some people go, oh, that's the bigger number. It must be more. No. So that was more acidic. So this is the pH of your tissues. That is the pH of your lungs. And hemoglobin is designed to bind oxygen tightly at 7.4. And then when it enters in a different pH zone, the shape of the hemoglobin changes slightly. At 7.38, it is more likely to give the oxygen away. So when it slows down your capillaries and it's in an acidic environment, it releases the oxygen. When it is at your lungs, it's a more basic environment. By comparison, it now binds oxygen. And a very slight change in pH is all it takes to do that. There's multiple factors. Temperature will also affect it, which is why on a hot day you find it difficult to breathe and you're getting enough oxygen. It's because it's warmer at your tissues than your lungs normally. So warm air tends to release oxygen. Unfortunately, if the air is really hot, that just means your body has a harder time binding to that oxygen. You're relying on pH more. Anyway, let's see what that difference is in actual numbers. Support my biology 12 colleagues. Calculate those out. Show me your answers. Work with a partner. Excellent. First one good.
Wait, can you scroll up for a second to see what the other?
Oh, it just says pH and concentration of H plus. So I want to make sure you can use the 10 to the X button on your calculator essentially appropriately.
It's just 1 times 10.
And please get out the calculator you're going to use on a test. Not your iPhone, not somebody else's calculator. Make sure you can use yours.
I forgot my calculator.
if you forgot yours,
Yeah, well, it's.
please hold up your right hand
I think it was just
and smack yourself across your face because I'm the last.
10 to the power, what's next?
Have I ever hit a student? No. September of '99. I had a teacher in grade 7 called Mr. Scrace, Courtney Jr. Middle School. You know those desks in which you have the desk and there's a big metal rod and your teacher's like, your seat is firmly attached to it, so like it's all one unit. He was short, he was like 5'3", but the gym teacher and loved working out. He's still the widest, biggest person I've ever seen in terms of sheer muscle, like in the flesh. He used to have a habit of throwing chalk at us if we were. So if you were saying something, you know, a piece of chalk would like ricochet off your skull from the front of the room. One day, we convinced a friend to throw the chalk back. And it bounced off the top of his skull. He was bald, left a mark. He came back because he was angry, like all the blood's flowing to his muscles. He like swelled up. He picked up the desk with one hand, with the student in it, just lifted it up, turned it upside down so that the student fell out, and then dropped the desk on top of it. So I've never seen a teacher hit a student, but I have seen that. Eight years ago, still relatively recent.
Yeah, and there was this gym teacher, and he was like, there's a story on like, I forget what the kid did, but he refused to do a block on him, the teacher just slapped him. And there was another one, like, some kid threw like a half-eaten banana, and he was like, there's people who could have eaten that, and he like dumped the garbage on top of him and pinned him against the wall. Like, fake hit him, like just a bunch of stuff like that.
I'm assuming he was put on some sort of probation and taken away.
I don't know, but he's been taught for a few years before.
Well, an entertaining read. There is a official teacher. You've been bad. It's open to the public. If you know where to go look for it, you'll find it, and it will say all the disciplinary matters that happen to teachers in the province of British Columbia. So you'll see like teachers who texted students inappropriately, teachers who like hit a student or whatever. They're all there, and what the disciplinary action was.
Find grammar teachers in there?
Pardon?
Will we find grammar teachers in there?
I haven't found. There's a court case that involves a teacher.
Really?
How do you answer load?
What was that case?
But was it the one with the
The student who was on who wasn't on leave, who went on leave.
No.
Why are you writing with your iPad?
Anyway, that's not here or there. I mean,
I
I don't know
was
where he's
thinking
working.
about the one where
Are
he
you
told
saying
us
you
that
find
he touched him and then he called the police or something.
Oh, that wasn't a court case though. The police
Yeah.
officer basically just said he can't touch students, and then to the students like, "What are you doing? You a dumbass?" Like, he clearly wasn't doing anything.
It's just the
Because
same.
for the police officer, it's clear that nothing is happening. He's not worried about abuse, and now you just wasted resources. He has to show up. He has to tell them like, "Don't do that," because if you keep doing it, that could be something. Good. Ah, where is it in your calculator? It's off in the second function log. Yeah, second function log right there. In the X. Oh, so to undo a log, it's off in the second function log. Did you find it in yours? Excellent. Oh, you good.
Right out.
Like the sharps. The sharps have been very reliable.
So you go, what? You go
Knowing how your calculator is programmed is important too, because you should learn like BEDMAS as an acronym or something for like brackets and stuff. It's like that is taught differently in different places around the world. And so not everybody,
I just didn't.
nobody mathematicians disagree on the order of operations in complex situations. And so they have to make a decision what they program to take. So if you type in a formula, two different students using two different calculators will get a different answer. But that usually is not something you'd see here. Okay, where's
As long as you know how to get to it, you know that like this relationship. As long as you know this relationship and you know how to put
No, bro, because like what I was doing is I just
it's really just this. If you know that, then you know how to put this in a calculator.
okay? Anybody not done?
no, aren't you just needed 10.7? 10.
I would.
We ain't lazy like that.
I'm also gonna. The next topic I think is sig figs. So by process of elimination, I want you to figure out how I'm calculating sig figs. So you're going to give me the answer. I'm going to give you the answer here to the correct number of sig figs. Nicholas Meyer, answer to the first one.
1 times 10 to the negative 3. Oh.
How many sig figs does that have?
1.
1.
It's got 3.
If I have 1.0 times 10 to the minus 3, how many sig figs does that have?
2.
2. Where'd you count them?
The 1 point.
The one there. 2 sig figs.
So 0 sig figs.
Yeah, that's 0 sig figs.
That's crazy.
Well, you're basically saying if you had like 10 to the 3, which is easier for my brain to work in because that's 1,000. What you're saying is the answer is 1,000 plus or minus 10,000 or 100. Like it's not really a sig fig. It's just like a ballpark. It's so error prone. We don't consider those sig figs. They're just decimal placement. So yeah, we got the decimal, but we have no idea what the numbers are. That's 0 sig figs. So when someone tells you a pH of 3, you have a vague idea. But it's not considered it's more qualitative than quantitative. But if I have 3.5, not here. Ella,
10 to the negative 3.5.
yes. What is that?
Oh, 3.16 times 10 to the negative 4.
3 point.
3.2 times 10 to the negative 4.
How many sig figs does this number have? 1. So that means this number had only 1 sig fig.
Okay, so should it be equal now?
Yeah. So I'm from this data, we are calculating. This is telling us the number of sig figs. This is 1 sig fig.
Wait, 3.5 is 1 sig?
Wait.
1 sig fig.
But there's 2 is 2 sig.
No. Stop arguing.
How is that?
No.
That explains. How does that make sense?
Just feel it for a moment. Just feel it. Just feel it. These are regular numbers. These are regular numbers that you encountered tons. What are these? They're not decimals. They have a decimal and represent, but secretly, what is this?
Number.
What process happened to this number to get it? It's on the pH scale. What mathematical operation did you have to do to get that number?
Oh, estimate.
You didn't estimate.
Negative 4.
You did the negative log. Now, when you multiply something by a negative number, it doesn't change the sig figs. But if you take the logarithm, if we have this, if I have 3, that number just goes there. That 3 is here. That has no bearing on the sig figs. It didn't have a bearing here, so why should it here? What a logarithm is that this, I want a different color. This part is the exponent of I keep wanting to say a real number, but that means something different in math. An authentic number. I don't know. I'll use it. This is the part that's the exponent. That is the part that is the number. So the 0.5 is what gives us this. Because if we just use that, it's 1.0 times 10 to the minus 3. That 1 is just a placeholder. It's just 1. This is the part that is telling us. It's just 10 to the minus 3. This, however, changes the number. So it's 3 times 10 to the minus 4. So 3.5 and 3 times 10 to the minus 4 are the same number. One is just the logarithmic form of it. When you take a logarithm, the exponents are before the decimal. No, I get questions. Now, when I did that, one of the reasons I asked you to do this is because you can see that this number, when you take the log of it, collapses into 0. So times 10 to the minus 1 becomes 1. This part just became that part. To change anything else, you have to change this. So if you didn't have 1, if you had 5 times 10 to the minus 2, then you'd have a slightly different thing. But this part and that part are the connected parts. The number before the decimal is the exponent. It tells you how big the number is. If you have a logarithm and the logarithm is equal to 100, then that's a pretty big number because you're talking about something times 10 to the 100. So for sig figs have to take that into account. So all the regular rules you know about numbers don't apply to logarithms because logarithms have taken what the number is and collapsed it into a single number. And so if we had 3.5, well, we have just one sig fig. That's the only one that changes this value.
So for the next one, is it 2 sig figs?
Yeah, so the next one's 2 sig figs. So what would it be?
5.0 times 10 to the negative 5.
10 to the negative 5?
Yeah.
Perfect.
Whoa, 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 whoa. I got 4.26.
Oh, really?
Yeah.
Okay.
I want to see your cut because maybe you're using the wrong 10 to the x. Try it again.
No, we got 4.272.
12.
No, I know, but I want to see your calculator. Which calculator did you use? Oh, you used someone else's calculator.
I got, not Pete.
Oh.
No, got it, but we have to put it in the right sig figs.
Oh, wait, is it? Ah, no, I didn't do the set.
Oh, that would make a huge difference, yeah. Small changes to logarithms, logarithmic numbers, make huge differences to the actual one.
Yeah, I didn't do that.
Yeah. So if you didn't include the 7, we just know that will change the number. Okay. So, 1 second. What is the number then?
4.3.
4.3?
Wait. No.
Okay.
Okay, wait. So if you said 4.26, would it be wrong?
Yeah. Wrong sig figs.
Oh,
Now, remember, I said at the beginning of the year, in Chemistry 12, we pick one question to mark sig figs on. And the only question we ever pick is the one with logarithms on it because it's the only new thing you learn this year. We tend to ignore unless you are completely wildly out of touch sig figs everywhere
So
else.
the output should have one less sig fig than the data that we were given?
Unless the data you were given was like, because yes, I can come up with scenarios where it's
Let's
no.
not do that. Let's
Because
just stick with
because
this.
yes, because if it's like that, you go, oh yeah, it's one less, so that's 1, so it's 0. But what if I said, oh the pH is 0.32? Then you go, oh, one, that's 2 sig figs, and it'd be 2 sig figs over here, because you'd ignore that. But you could also write that as just 0.32. So I can mess with it a little bit, but on average, your shortcut, as long as you don't get messed up with that, would work. Yeah. 7.40 becomes. I forgot I was asking people. 3.9 times 10 to the.
Negative 8.
And 7.38.
4.1 times 10 to the negative.
This is.
Wait, for 7.40, can't you just round that up to 4.0 times 10 to the negative?
No, it's
No, because you need 2 sig figs.
Because you need 2 sig
This is 2 sig figs. Now that is 2. Was it 9.9?
9, 8.
Oh, is it 9.8? Everyone else?
yeah, it was
Yeah.
nine.
Oh, then it would be 4.0.
So yeah.
And the second one is 4.2.
And the second one's 4.2? Because
Wait, how does it being 9.8 make
So
it
it's
4.1?
So you
4.17.
round up to 4, and then.
Yeah, but
you
like,
add
isn't
sig
4.0
figs,
still
so you add
just one
0.0.
sig fig?
No.
No, let me do it from the beginning.
Minus 1.
This is grade 11.
If you put
What is the full number for this one? Like to multiple?
3.98.
3.98 what?
I don't know.
that's enough though.
It is enough. It doesn't matter. I'll just say 6. And that'll confuse it. 981? So 981. So we know we have to round here, right?
Yeah.
So when you round, you look at the one next to it. You don't look beyond, you just look right next to it. If it is a 5 or above, you round up. So how do you round 9 up? Bump it up, becomes 0, and that becomes 4.0. So for this one, it was 4.117. So you look at the one next to it, that rounds it up, 4.2. No, I don't want a GeForce Game Ready driver. This shows how tightly controlled the pHs of your blood. I've seen diet products online and advice where they tell you don't eat acidic foods, don't eat basic foods. If you know a little bit of knowledge, then you're like, oh yeah, because that can really change your blood pH. But once you understand, I mean, a lemon can be a pH of 3. If that was actually possible, you would eat a lemon and then die. Your liver and your kidneys make sure that your pH does not change. It does not matter what you eat unless you do something very extreme. Like you're going to eat nothing but meat. No carbs, no fats. You'll just get ketosis and eventually you'll smell acetone on your breath. Then you'll get into acidosis and then you'll die. But you'd have to be really extreme about it.
I tried that.
Did you try a full?
Yeah.
Were you eating fat?
Yeah.
Fat helps.
But isn't meat half fat?
You can also, if you also eat, there's something called rabbit starvation. It happens.
Well, like an all meat diet is the whole point is you eat a bunch of fat.
Sure,
But it depends on what.
but if you aren't eating, because there are people who have done this to themselves because they say, well, I'm worried, and so I'm going to try all protein because they hear that protein is good, so they go all protein, no carbs, and then they also, because they're trying to lose weight, drop all the fat. Rabbit starvation, your body can't process protein for energy without another source of carbon. The fat provides that carbon. If you don't have the fat, then you can starve while eating nothing but protein.
I probably meant like with fat.
But if you go to a strict no carb, even just protein and fat diet, you won't starve to death, but you can put yourself in acidosis. You need a certain minimum amount of carb. If you're on like, I don't know, the Atkins diet or any of those really low carb diets, they'll still recommend a certain amount to the point they sell test strips for acidosis on Amazon to make sure you're not going over the amount for the people who want to like walk right up to the edge of the amount of meat that they're eating. But you do need a small amount. You can get yourself in real trouble if you don't. If I will say, do be careful because any extreme diet, there is one research proven effect. Any extreme diet tends to lead to eating disorders. So whatever you play with, make sure it's a diet you can live with, and it's not something that's just you're going to bounce around from. 12.32. A Red Bull diet. Max. $12.32. I think I signed that one afterwards.
Oh yeah, I did that.
No, that was 0.32. I'm going to add that as a new one. Quickly on your calculator, what is 12.32? 10 to the x. Oh, you don't have your calculator.
Oh, it's in my bag. I packed it up. So.
Why would you pack up your bag?
Oh no, just unpack it.
Okay, so how many sig figs is that?
That's my.
So how many sig figs is this?
4.
No.
3.
2.
2.
2. It's a logarithm, so it's a pH. It's a pH, so we only count the ones after.
Can I have help with my calculator?
Sure. What number did you get?
Oh, I thought you were doing 0.32.
4.78 times 10.
No, 12.32.
4.786 times 10 to the negative 13.
What? Really?
Yeah.
What did you get?
4.786 times 10 to the negative 13.
Oh, well, that makes more sense. I misheard what you said at first. And to the correct number of sig figs, that would be
4.8.
4.8. Okay, I'll come up with some more.
Can we take a break?
What?
Point break.
10 to the, did you use?
I'll use the one above my log.
Oh, that should work. 10 to the 12.32.
The same thing's happening to me.
Oh!
Can I give you my exception?
10 to the negative pH. Minus 12.
Oh,
Try that.
it'll be negative.
Yeah, because our answer's like 10 to minus 13. Remember, pH is a negative log, so you have to put the minus.
You have to cancel.
Yeah.
What? Okay,
Yeah, I can't.
You just know. It's okay.
It's fine, it's fine.
Okay, calculate the pH. Those ones are too easy.
Too easy.
Too easy.
Are we supposed to use?
Yep. Pure water is pure water, freshly distilled, hasn't been sitting out, hasn't been added anything, not exposed to the atmosphere. Questions yet? Your process? Oh, you're not. How do you calculate pH?
You do.
I see he is too.
Yeah, so how did you go from here to here? Calculation. What do you
These two. No, because H has 3 kilograms.
Negative one.
Yeah.
So that's equal to the amount of
So
H.
for all these ones,
So 0.01 molar
we need to take,
which is 1 times 6 molar.
we do log of H.
No, I'm talking about these.
Right, so,
But then this one, we're gonna
yeah, I noticed, I did a bunch of examples before, you have done bridge routes, haven't you?
And AOH.
Oh.
Is
Right.
AOH also?
So what is the opposite of,
so
the logarithm, 10 to the x? Yeah, you're just doing this.
I have a
10 to
question.
the minus pH.
So like, I know like for, if it's pH, right, it would just be 10 to the negative 6.
Yeah.
How do I, what's the, what is the
Yeah.
difference here?
What- So you need the pH in order to do it.
Okay.
So how would you get the pH from the pOH?
It's just the opposite? So would it be like, if it's between 0 and 14?
Right? There you go, yeah. I can't say yes to opposite, because the opposite is 6. It's not 8. But
Oh, it's only.
But it's not
in
negative.
how you were doing it in your mind, I think you're right.
It's not negative,
So
right?
then the next one.
Just 8,
It's
yeah.
pure
The
water.
next one has OH.
It's so damn.
No.
So the-
Well.
Like pure water is 7.
So
It's neutral.
5.
Yes.
What's next?
Why does it say H2O rather
Can you
than?
imagine if pure water wasn't neutral?
Yeah.
Wait, then why is that Ka?
HCl fully reacts, right? Yeah.
The Ka of pure water is, remember, so the Ka is based on this reaction, pure water. Goes to H plus. This OH plus, right? So Kw for water is concentration of H plus times concentration of OH minus.
Yeah.
Right? So 1.0 times 10 to the minus 14 is equal to, and this turns out what two numbers, if they're identical, equal that?
Oh, okay. 7.
Yeah, so they both are 1.0 times 10 to the minus 7. So 7 is the midpoint, because that is the point at which they are both the same.
What
And
the
then that's gonna be
hell?
1.0 times 10 to the negative.
How am I supposed to do F for the first one? 1.5.
1.5 molar ECl.
Negative 8.
What's wrong with them?
How can I make this times 10? Is it just 1.5 times 10?
Why would you make it times 10 to that?
Then you find the pH.
Right, how do you find the pH?
Oh, you have to.
What were you doing just previously?
Finding the pH.
Right. And finding the pH, you take the They write it down here. Negative. Oh, yeah, okay. There you go.
I need this.
What do you think you do with it? What is it?
pH is negative.
Was it negative? Negative.
For HCl, is the pH negative?
Is it? What do you get?
Negative 0.17.
Negative 0.17. Does that make sense?
I mean,
Is it-
It's negative. It's the negative log of 1.5.
Yeah. I mean, if it was a pH of 10, sorry, it was a concentration of 10 molar, you would have negative 1. You're not, and if you had if it was 1.0, it would be times 10 to the 1 point. If this was 1.0, it would be 1.0 times 10 to the 0. So without going up, you're already at 0. And the only place you can go to get more acidic is
Oh, yeah.
down.
How do I do this one?
How many are up here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many people we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
Oh, you just take the negative log of
14.
But I think it's more
So,
it says OH.
Why don't I do it this way?
And you minus 14.
I will do it this way. I will say,
I got 5, so it's.
oh, not here.
Okay, wait, when you say
This is the wrong class.
negative,
Nathan,
Yeah.
stay where you are.
X is where.
Okay. And Andrew, stay where you are. Everyone except for Nathan and Andrew have to come up and in a different color write up one answer. We have 2 more people who may have questions. So I randomly picked the 2 that could sit back and relax and watch
I have
everybody
that
else.
pen. Thank you.
Wait for Josh. For Andrew.
Right?
Pardon? will take 2 at the same time, I think, for writing if you use your finger. I don't think it takes 3.
Can you go grab it? I don't remember what it is.
Good idea.
I need mine.
How do you erase? Oh yeah, that's right.
That's wrong. How do I erase? That's the wrong side. How do I erase it?
There's an eraser button, but warn people. Because if you do that, everybody's erasing. There you go. One person, other than Josh, who hasn't come up. Theo, have you been up?
Yeah, I put the 11.
I think it was Gleb.
No, trust, I definitely went up.
Yeah, definitely was Gleb. Thanks.
I'm still writing it down somewhere. Chill.
Josh, do you need help? Two that are left are 2D and E.
Wait, did you have 11 for one?
How do you see it?
Look at
How do you
one.
convert LQH backwards?
Negative 0 point.
Because it's OH.
One,
And then
negative
11
0
plus
point
E
something.
is 14.
But you're not just writing the answers down.
E is a 9, isn't it?
But
Why is it 5?
this is recorded, you can get the answers there. But how do you do the ones on the other side?
I'm sure E is 9.
Which one are you doing?
E.
E?
I can do both.
No, no, no. Just leave one. How'd you get that? Did the 10 do that? Excellent. Throw that on. Now, how did you get that?
What?
Very good.
I think that, no, Gleb, that's the
Yeah.
answer for D. That you just put there. You just put it at the wrong.
Oh, did I? No, that's for E. I got that for E.
I got that for D. I got that for D.
How'd you get that? How'd you get it?
Just for E, what I did is
Yeah?
14. My 5.6, so I got 18.
Yep.
And then I just put that in, so negative 8.4, which is,
If you switch them, so that's gonna be
Yep.
11.
You were right.
No, it'd be 14 minus.
I think Gleb's right.
What?
Yep.
OH is 3, and H is.
That's what I got this.
And it's asking for pH.
Oh, because it's OH.
It's OH.
They might be the same answer.
No.
They are the same. Oh, yes, it is. 'Cause
Mr. Newton.
yes, it
Yeah.
is.
I would put
D and E
the
have
answer
the
is
same
the same.
answer.
The answer's the same for both D and E.
Yeah.
Yeah, I know.
Oh,
No, it's
That's
over
right.
here.
Oh, wait, 1 second.
yeah, D.
If you're an acidic solution, is your pH above 7 or below 7? Below 7. If you're an acidic solution, is your pOH above 7 or below 7? Above 7. So if you have a pH of 7.4 and a pOH of 5.6, they might very well be close enough because they're above and below 7 to give you a very similar answer. And we're only going for one sig fig here, so any minor minutia in detail would not be there. So I did look and make sure that you're going to be converting those, which, well done. Pure water is 7, that's 10. This person correctly went 3, 14 minus 3 is 11. This is a strong acid, so that is just 2. 1, 2, 3, 4, 5, NaOH. There is a little problem with this one though. It should be 9 because what's here is the pOH. So the pH is equal to 9. And who squished this one in here? What is that number? Negative 0.18. Excellent.
Wait, how is B 7?
So how is
You were close, Kate. Yeah.
how is which one which?
B 7.
B. What is neutral?
Right, it's 7, but shouldn't it be 10 to the negative 7 and then that number be in the negative log?
I asked you for the pH. That's the pH of 7. The concentration of H plus
Oh, right.
in pure water is is it not plugged in? No, it's just not on. There we go. To there. What do you not till 1:15?
It's 115.
No.
Yeah.
But no. I don't want to do the thing where I wait till everybody has their books out and you get dismissed at 1:17. So let's wait until it is actually 1:15 and I dismiss you before we start packing everything up. Because with the amount we have left, we do need to go all the way to the end every single day. And there is the bell. Okay, W is per minute, so we will do that next day.
Thank you.
Thank you. Reminder, what's next day? Quiz.